Good afternoon, and thank you very much for joining us today. I would like to thank first Bigamel and the EOI for giving us the opportunity to be here and present one of our current use cases. It is smart energy management, and well, as Maria Jesus said, we are Cristina Rodriguez and Eliot Olivia, and we belong to the R&D and I department of Talento. First, speaking about our use case, I would like to tell you a little about our company. It is Talento. It's a technological company located in Gijón, in the north of Spain. We are focused on digital transformation of companies, and we have been doing this long before this term became popular. So, especially, what does Talento do? We like to call it intelligent digital transformation of companies, and this includes several business lines. They are custom technology, technological innovation, digital communication, analysis and strategy support, and education. And focusing on technological innovation, that is the area to which Delio and I belong, we have blockchain, machine learning, IoT, virtual, mixed, and augmented reality. So to start now with the project, I would like to context it and see the background to understand then our solution. Our project deals with energy efficiency of companies. In these terms, the European Union has several policies to improve it. There is a European directive to 2012/77 that established the obligation of large companies to pass energy audits every 4 years. So our solution intends to be a help for those large companies who must pass energy audits every 4 years, but also for small and medium enterprises who want to start controlling their energy consumption. So due to these audits, the consumers of the company are defined. The consumers can be, for example, the lighting system, water, electricity, gas consumption of the company, etc. It depends on the company. So once the consumers are defined, energy saving measurements are established to improve the consumption of that consumers. And then to implement that energy saving measurements, the company must sign energy contracts with energy service providers. And the particularity of these contracts is that the payment is not executed until the conditions of the saving measurements are accomplished. So our solution, Smart Energy Management, combines the 3 different technologies. They are IoT, to automatically collect the data from the sensors installed in the consumers of the company, then machine learning to analyze those data, and blockchain to automate the payment between the company and the energy service providers. And now Delio is going to tell you how we do that.
We will try it. Hi. Micro. Okay. Well, this is the IoT part of our project. We take these consumers that are defined in the audit that Cristina told, and we put different sensors in them, like a lighting sensor, an electric consumption sensor, a gas flow meter, any sensor that we can detect the energy consumption of this specific consumer. This data is sent to our servers. We use an Arduino platform with different sensors, with a Wi-Fi shield to send the data to our server via an API that we made in our application. So the workflow of this part is the sensors take the data, send it to our servers, and are stored in a database. It's a very simple workflow for this part. In the lower part, you can see a screen of our application where you can see the factory electricity consumption, one of the variables that we are measuring with our sensors, where you can see the value that the sensors got, a timestamp of this value, 2 columns that we're going to talk later of them, and the last column of type, because you can put this data manually or an automatic way via the sensors. The 2 columns in the middle, the anomaly and anomaly probability, are related to the machine learning part of our project that we are talking now. Why do we use machine learning in this case? And specifically, we use VML. We got a lot of data from these sensors, and it's evident that we got to analyze all this data. The problems that we may find with this data is always the unexpected measures, but we can make also sensor calibration, a sensor that starts to measure not correctly, and we have to make a little correction to the sensor failures, total failure of a sensor, or these unexpected measures that we cannot prevail before they happen. We can prevent matching failures, energy supply failures, fraudulent use of companies' resources, but there's a lot of more cases that can be. The workflow of this machine learning part, we create, you can see it before in the morning, we create a source, then a data set, an anomaly detector, and afterwards we start to making prediction with the new measures of the sensors. We use anomaly detection. It's a yet not seen here anomaly detection, but it's an unsupervised learning method. It's capable to detect anomalous instances in unlabeled datasets. This anomaly detection gives us an anomaly score of the data. It tells us if this data may be anomalous in all the data that we have. How much anomalous is this data? We transform this in anomaly percentage, so we can act in consequence. We can delete this data, keep it for future use, or what we need. In a more detailed way of this workflow, first of all, we got in the center of the slide, you can see our application, Smart Energy Management. In the lower part, we got our sensors that take the data, store it in a database, and when we got enough data, a month of data of these sensors, a week, what we consider enough, we create a CSV file that is sent to VML via a call of the API and create the source in VML. This creation returns us an ID of this source that we use to make another call to the API to create a dataset. This dataset also returns an ID that we use to create the anomaly detector. And then the ID that the creation of the anomaly detector returns to us, we store it in the database related to the variable that we are going to take anomaly detection. Afterwards, when the sensor starts collecting another new data, every data that we collect, we send it via the API to VML using the ID of the anomaly detector related to this variable and send it the new data. And this returns us the percentage of anomaly of this one. We store it related to the data. And these are the 2 columns that we see before in the screen of our application. As you can see in the upper part is the 2 columns of anomaly and anomaly probability. Anomaly probability is the quantity of how much anomalous is this data. And the anomaly is a way to label that data as an anomaly. We take, if the anomaly percentage is over 60%, we label it as anomaly. Then the user, this doesn't mean that the application deletes the data or do anything. This only labels the data so the user can take the decision to delete the data or keep it. In the lower part of this slide, we can see the part of the application where we create the variables that we want to measure. These variables are related to the consumers, as we told you before. And the more important part of this screen is the first button. I think that you cannot see the text. It said Update Anomaly Detector, where you can click in this button and it automatically creates the workflow that we've seen before. He creates a CSV file, he sends it to VML, creates source, dataset, anomaly detector, and update the anomaly detector for this variable. It's a very easy way to get all the workflow of VML creation of the anomaly detector integrated in our application in a very automatic way. And the last technology that I want to talk to you was the use of blockchain and why we use blockchain in our case. As Christina said, in this case of use, the companies have to sign contracts with energy service providers to control the energy saving measurement. It's a very complex ESM, ESPs. It's very... and this sign of contract, this energy contract, has very similarities with smart contracts of blockchain. As we can see, these energy contracts are signed between these companies and the energy service providers, and they only be paid when some conditions are met. For example, a contract established that we have to reduce energy consumption of lighting system in a 20% in 2 years. So if in 2 years we can detect this reduction of 20% of energy reduced, the payment is then made. So with smart contracts, it's a very normal way to make these things. We got these smart contracts in our blockchain network, and we execute these smart contracts to make a transfer when we want. In this case, we implemented an Ethereum private network, and we programmed this transform of the real world to the blockchain world. We got our ESPs, our company, the energy contract, and the payment that is only made when these conditions are met. In the blockchain world, we got our smart contracts, and this relation between the wallet of the company, the wallet of the ESP, and the transfer of Ether, in this case, is only made or executed when the conditions of the contract are met. This is the workflow of this blockchain part, where we got our application. There's also the technologies for one who want to see the technologies that we use in every part of our application. This smart energy management, take the sensor data, send it to a database, collect the data, etc., etc., etc. And when the user wants to create one of these energy contracts, he makes a request to another server that, in an automatic way, create the smart contract in the Ethereum network. The user don't have to know how to create a smart contract or make anything in any language or do anything. Afterwards, we were going to see the screen that you create the contract. The contract stays created in the network, and afterwards, our server starts to check the data, the new data of the sensors related to that variable, and when the conditions are met, he goes to an execution of the smart contract. The execution of the smart contract is made, and then the transfer of Ether is made between the wallets of the company and the ESP. This is the screen of the application where you create a new contract. You only put which is the provider related to the contract, to the energy contract. You provide the ID of the wallet of the provider. the quantity of ether that is going to be the payment related to that contract, and the electric saving measure that we got to see, if it's a 20% reduction, if it's a 10% reduction, and the variable or the tracing of the variable that the program had to make. He got to make a tracing of the energy consumption of the lighting system. When the condition is met, the transfer is made. These are a little resume of the technology that we use in the project: Arduino, PGML, MongoDB, Ethereum. So you can see there's a lot of technologies. Now Cristina will continue.
Well, apart from smart energy management, we have other current use cases that we are working at in Talento, applying machine learning. They are, for example, Metalia. It is a machine learning application to production planning in the Asturian metal industry. The Asturian metal industry has some particularities that make it very appropriate to apply machine learning. This is because their production is non-serial, so every single structure they make is unique. For example, one of the companies involved in the project is now manufacturing the metal structure of the largest telescope in the world. And that's why this project intends to be a help for these companies to do this difficult task of planning. Then we have another project. It is IA Lift. It is a machine learning application to optimize the waiting time of ThyssenKrupp elevators. I suppose you know ThyssenKrupp. It is a more digital company than the previous ones, and they are really concerned about the value of data. So they want to start adding value to their services and products by applying machine learning. So what we are doing in this project is taking data from their control and monitoring system and then analyze it with BigML to give them our best solution. Then we have another confidential use cases, short pilots with large companies. In Talento, we are quite focused in the industrial sector. This is because in Asturias, the industrial sector is very important for the economy. So companies must adapt digitally to face present and future challenges. So what we want them is to become digital with us. Another forthcoming use cases that we will be working at in Talento soon have to do with predictive maintenance, process resource and consumption optimization, production planning, quality control, demand forecasting, etc. Thank you very much. And if you have any questions, we will be happy to answer you now. Si tenéis alguna pregunta.